So in this video, we will see about randomized algorithms. So in the normal algorithm, the algorithms takes input, so and then the input is processed by the algorithm, and then it delivers the output. So if you use any divide and conquer approach, dynamic programming approach, a greedy approach, the actual principle or working principle of algorithm is like this only. Take a input, process the input, and deliver the output. So in a randomized algorithm, so the algorithm takes a input and the algorithm is expected to deliver some output. So apart from the input, while processing the input, the algorithm takes some random value. So it is not give the input. It is not actually input. So the random values are generated by the algorithm, and by using that input with that random value, so it will generate a output. So there is the main difference between randomized algorithm and then the normal conventional algorithms. So the randomized algorithm, there are two types of randomized algorithms. First one is Vegas algorithms, and then next one is that Monte Carlo algorithm. So the difference between this Las Vegas and Monte Carlo algorithm is so both uses some random values or random steps inside that algorithm. So in the Las Vegas algorithm is designed in such a way that it always delivers the expected output. So but there is no time bound for this algorithms. So algorithms takes its own time until it delivers the correct output. And in Monte Carlo algorithms, so the algorithms are designed in such a way that it has a time bound. So algorithms takes, I mean, we can fix a maximum time bound for that algorithm. So if output is generated within the time bound, then it delivers the output. Suppose if the algorithm cannot able to deliver or generate the expected output within that time bound, then it won't deliver the correct output. There is no guarantee for the output. So in Las Vegas, it always gives the output. There is a guaranteed output, but no time bound. It takes its own time. In a Monte Carlo algorithms, we have a down bound to generate the output. If the output is generated within the time bound, then it delivers the output to the user. So others, the output will not be delivered. There is no guarantee for the output. So we will see one example for both the Las Vegas and then Monte Carlo algorithms. Suppose the problem is we have a array of size n. Suppose the size of the array is 100, means the numbers 1 to 100 are stored in the array, but in a random way. Random way means the index 1 may have a number, any number from 1 to 100. In the same way, index 2 may contains any number from 1 to 100. So that index I, that means the index I not having the number I. So index I have any random number between 1 to 100. So this is the input you have, and from that input you need to find the correct index of a particular number from 1 to n. So we have a input, we have a array, the size n, that value stored in that array is 1 to n, and you have a key value, some key value, and we need to find the correct index of that key value in the array A. So actually, in a normal conventional method, we use one for loop. That for loop runs from value 1 to n, and yeah, in each index I, we check that particular index I with that key value. If that key value matches in that index I, then we return that index I. This is the normal way. But the same thing can be implemented using randomized algorithm also. So the first one, Las Vegas, we execute a infinite loop. So this is a infinite loop, and each iteration I generate one random number, the random number between 1 to n. So that that random value is now used as a current index I, and I'm checking whether that key value. So whether that key value matches with the value stored in the array at index I. So this I is randomly generated, and then I check whether the DAA of I is equal to key. If it is true, then it will return that index I. Suppose in the current iteration, the random index generated I is not matched with that key value, then it will go to the next iteration and generate the next another random value and check that index with that key value. So if it is matched, it will return. Otherwise, it will keep execute the same process until it find the exact index value. So this is Las Vegas. Why this is Las Vegas means so this while loop is an infinite loop. That while loop will be terminated if we that random value generator generate the correct index value. So when the correct index value is generated, then only the if loop will become true, and that while loop, yeah, after returning that I value, the while loop will exit. So it always it is there always generate the expected output, but we don't guess how many times that while loop will be executed. So if the n value is the size of the array is 100, means in some time at the first iteration itself the while loop may break, or sometimes within 100 iterations the while loop may exit. But in sometimes if we are unlucky, so that random number, the correct random number will be generated more than 100 try, even 200 tries, 300 tries, 500 tries also it may go. So there is no time limit, time bound for this algorithm, but it generates the correct output. So next, the same problem can also be implemented using Monte Carlo approach. So as I already told you, the Monte Carlo approach has a time bound. We can fix the time bound, the maximum time we can fix. So we can fix a polynomial time. If the size of the input is n, means we can fix the maximum time is O of n or O of n squared, anything. So as per our requirement. But here we cannot expect it always deliver the output. So here for the same problem I use a repeat statement. So this will be executed for 200 times. So this iteration, these loop statements will be executed for 200 times, and each time a random value is generated and random value is used as a index, and the key value is compared with the value in the array stored in that particular index. If that key value is matched with that index value, then it will return the index. So here this iteration, this loop statement will be executed for only 200 times. If within the 200 times, if the correct index value is generated by this random number generator, then the program delivers the correct output. Suppose in the all the 200 times, if the correct index value is not generated randomly, then it won't deliver the output, but that program will exit. So it has a time bound, but there is no guarantee for the correct output. Okay, so that is the main difference between Las Vegas and Monte Carlo. So what is the need for this randomization algorithm means? So in some cases, so this is the main application of this randomization algorithm is to reduce the worst case time complexity of the existing approaches. So in some algorithms, it may deliver maximum or maximum worst case time complexity. So we can use this randomized approach to reduce the worst case time complexity, or to escape from the worst case time complexity of algorithm. So these are the examples for these randomized algorithms. So randomized quicksort, and randomized hiring problems, and randomized search tree, that is TRIP. So These quicksort, hiring problems, and search tree, they have a worst case. The best case may have, for example, in the quicksort, the best case time complexity is O of n log n, but the worst case time complexity of quicksort is O of n squared. So if the input is already shorted, so the pivot element is selected in such a way that it always small or always larger. So this randomized quicksort may help to reduce the worst case time complexity of the existing quicksort algorithm. The same way for the hiring problems and search tree also, to escape from the worst case time complexity, we may use these randomized algorithms, randomized hiring problems and randomized search tree. Okay, thank you.